This movie is about calculating compound interest. We talked about this in class already, but just to help you clarify what's going on here, here's a little video. So interest is the percentage of growth of money saved or owed, and we're going to look at a savings account this time. So let's say you put $5,000 in a savings account that earns 6% interest per year. We call that APR, the annual percentage rate. So we know we need to start with a table. After 0 years have gone by, we still have our original amount, $5,000. After 1 year has gone by, how do we figure that out? Well, a lot of you like to do the two-step approach where you find 6% of 5,000 and then add that to the original 5,000 to get 5,300. Of course, it's a lot easier if you just do it all at once and say you're doing your 100% plus your 6%. So 5,000 times 1.06 still gets you your 5,300. Did it in one step. So 5,000 times 1.06 is 5,300. After 2 years, you can multiply by 1.06 again and you get 5,618. Times 1.06 is 5,618, and we can keep doing this. We keep multiplying by 1.06 and we can see our amount of money increases. So we start with 5,000, then 5,000 times 1.06, then 5,000 times 1.06 times 1.06, then we multiplied by 1.06 3 times, then 4 times. And of course we can write this in a shorter way. 1.06 squared, 1.06 to the third power to the fourth power. We've done this before, that's why I'm kind of rushing through this part. So after 100 years, right, we know we're going to have 5,000 times 1.06 100 times. So 5,000 times 1.06 to the 100th power, because we have repeated multiplication. So for x, we're going to have 5,000 times 1.06 to the x power. We found our function, great. We can use it to figure out how much money we'd have after 10 years. Plug in f of 10, and we get $8,954.24. So that's just letting our money sit in a bank account, earning 6% interest. After 10 years, we have almost $9,000. That's pretty awesome. So we went through that quickly because it shouldn't have been that hard. It should be review. You've done that before. But this next part, while you did it in class once, you may not have quite understood it. So let's say we have the same exact situation, except this time we're going to get half the interest, or 3%, after the first 6 months, and half the interest, 3%, after the second 6 months. This is called compounded biannually, or twice per year. So again, we have our table. 0 years, we have 5,000. But this time we're only going to go up by half of a year, because we're getting 3% of our interest in that first half of a year. So we'll multiply by 1.03, and we get $5,150 after half of a year. After a full year, well, we get 3% interest on our new amount. So after a full year, we multiply that by 1.03 and we have $5,304.50. After another half of a year, so 1.5 years total, we're going to multiply that by 1.03. 2 years, we've earned another 3%, etc. So we have 5,000, we have the same picture, but this time we have 1.03 instead of 1.06. Same work, right? Same shortcut, 1.03 squared, 1.03 to the third, 1.03 to the fourth power. But now when we have the 100 years have gone by, we have a problem, because we look and we see, we know 5,000 times 1.03 to some power, but we don't know what power to use anymore. Because if we look at the years, they don't match up with the exponent. So after 1 year, we have 2 as our exponent. We've multiplied by 1.03 twice. After 1.5 years, we have 3 as our exponent. We've multiplied by 1.03 3 times. And after 2 years, we have 4 as our exponent. But hopefully you can still see the relationship there. We have 4 is twice 2. 3 was twice 1.5. So we can see that the exponent seems to be twice the number of years, which makes sense because we are earning the interest twice per year. So after 100 years have gone by, we have an exponent of 200 because the interest has accrued 200 times. Only 3%, not 6%, but 3% interest 200 times. So for x, the interest has accrued 2x times, 1.03 to the 2x power. So after 10 years, how much do we have? Well, we just plug into our new formula, our new function, and we get 5,000 times 1.03 to the 20th power, because interest has accrued 20 times, giving us $9,030.56. Well, that's interesting. So let's just compare our compounded annually with compounded biannually. So we can put in our years, and when we compounded annually, we had 5,000. That's how we started. After 1 year, we had $5,300. After 2 years, we had $5,618. After 10 years, we had $8,954.24. This is just coming off of what we already did. This is what we did the first time. Then we compounded biannually. But before we get to that, let's look. What is happening after a half a year? Well, we haven't earned any interest. We still only have our $5,000 because our interest doesn't get compounded until after a full year is up. After 1.5 years, we still have that $5,300 after we got the interest from the first year, but we haven't accrued any more interest. Let's contrast that to what happens when we compound it biannually. Well, we start off with 5,000, but after a half year, we have earned some interest. $5,150 is how much we have in total, because we've earned $150 of interest. And now we're getting interest on top of that $150. So now we have $5,304.50. Notice that we have $4.50 extra. We have $4.50 more than when we just compounded annually. And we keep adding, and our money keeps getting more and more because we keep earning more interest on more interest. So when we compounded biannually, we were given some of that interest earlier. So essentially we start earning interest on that interest earlier. If we look at this one right here, after 1 year have gone by, we've earned 6% on the 5,000, just like we did when we compounded annually. Why? Because we had 3% and then another 3% for a total of 6%. But we've also earned 3% on that extra $150 that we earned. So not only are we earning our 6% on the 5,000, but we're also earning 3% on the 150. That's why we have more money. 3% of 150 is $4.50. That's where that extra money is coming from. So if you look at all the numbers in the compounded biannually, we're earning more money. So we would rather compound it biannually than annually. It seems like it should be the same, but it's not, because we're earning interest earlier. So we're getting interest on our interest. Let's look one more time. Same example, but what if we compounded monthly? Well, 12 months per year, so 6% yearly is the same thing as earning 0.5% every month. If we earn 0.5% every month, that's 6% yearly. So let's look what happens. When we have 0 years, we still have our 5,000. Now after 1/12 of a year, right, because 1/12 of a year is a month, which is when we're compounding our interest. So after 1/12 of a year, we have 5,000 times 1.005, which is 5,025. After 2/12 of a year, 2 months, so we have to multiply by 1.005 again, because again we get that 0.5% interest every month. So that becomes 5,050 and 13 cents. We can do it. Another month has gone by, or another 3/12 of a year, 4/12 of a year, another month. And we can see that we have 5,000 and 5,000 times 1.005, etc., etc. We've seen this before. The only thing that's different is it's 1.005 instead of 1.03 or 1.06 as we had before. So we see we can write it in a shorter way, just like we could before, using exponents because we have repeated multiplication. Now we have to find that connection between our years and the exponent. So when the years was 4/12, the exponent was 4. When the years was 3/12, the exponent was 3. In other words, how do we get from 4/12 to 4, 3/12 to 3? Simple, we just multiply by 12. 4/12 times 12 is 4. 3/12 times 12 is 3. So we have 100 years. We would have, well, what would that be? 100 times 12 to get our exponent. So, because when it was 4/12, it was 4. So it's 1200. So 100 times 12 is 1200 or 1200. So 5000 times 1.005 to the 1200 power. For x, we have 5000 times 1.005 to the 12 times x power. And we can look again after 10 years, how much do we have? Plug it into our new function. F of 10 is equal to 5000 times 1.005 to the 10 times 12 is 120 power. And we have $9,096.98. So as we can see, the more often you compound the interest, the more money you will get, because you are earning interest upon interest early on. In class, you're going to be asked to write a formula to predict the amount of money you will have given the original, which we call the principal amount. When you're given the principal amount, the APR, and how often the interest is compounded. You should think about what that formula should look like. You could even probably figure it out right now. You'll need to use the notes from this video to help you find the formula. In other words, you need to write a function. The notes in this video will help you do that. One more thing to think about before I let you go. What if you compounded your interest at every single instant? Not every second, not every tenth of a second, not every millionth of a second, but continuously at every single instant you're compounding interest. What do you think would happen then? Mind blown. Okay, so think about that function. Think about the formula that you're going to have to get.